Okay, beginning here, we have a lesson on solving radical equations. This is day 2. Shh. Same thing as yesterday. Big idea again is getting the radical sign by itself, okay? And then you could square both sides. What's the inverse of the radical sign? What's the inverse operation? Squaring, okay? So, here are the steps again from yesterday. Today's just going to be a little bit more complicated. And we're going to really focus on this last step today, checking for extraneous solutions. We didn't really need to worry about that yesterday too much, but today we will. Okay? Number 1 and 2, watch carefully, pencils down. Okay, number 1, first thing I'm checking, make sure my radical sign's alone on one side of the equation. It is, so I'm going to square both sides. So we're going to have 6 plus x is equal to x squared. I'm going to combine like terms, move everything to one side, so I'm going to subtract 6, subtract x. And when I do that, this becomes 0 is equal to x squared minus x minus 6. Then I use x box or factor, so 0 is going to be equal to x minus 3 times x plus 2. Then I'm going to use the zero product property. We've got x minus 3 is equal to 0, x minus 2, or x plus 2 is equal to 0. So x is equal to 3, and x is equal to negative 2. Okay, 2 answers, right? Now we're going to check for extraneous solutions, okay? This is how we check. What you should do is just draw like a little T-chart, okay, for each solution. And basically all I do, let's try 3 first. So we plug it into the original equation, so it's going to be 6 plus, and we have x here, so x, we're going to try out 3, is equal to x. So x is equal to 3. Okay? Now remember, our original equation is just this up here, okay? None of those other annotations that we had up there. Okay? So 6 plus 3 is 9. So square root of 9 is 3. And then we ask ourselves, is 3 equal to 3? Does that make sense? Yeah, it makes sense. So we know that this is definitely a solution. So we know this is a good one. Okay, let's check this one, negative 2. So we got 6 plus negative 2. Square root is equal to x again, which is negative 2. So 6 plus negative 2 is 4. Square root of 4 is equal to negative 2. Square root of 4 is 2. Then we ask ourselves, is 2 equal to negative 2? Does that make sense? No. Yes or no? No, it doesn't make sense. So even though we did solve this, even though this should be an answer, it's not, because it's an extraneous solution. It would make, this is a false statement. 2 is not equal to negative 2. So when we take a square root, take the principal square root, which is the positive one. So we do not want to include this one, x equals negative 2, extraneous solution right here. Okay? So the only correct answer is this one. Yes?
So on the test it says give the answer, and it has like those two, and then just 3 by itself. You just
put in 3 as your answer. Don't pick negative 2. Okay? If you pick negative 2, then it would be wrong.
No, what if there's like 3 and then x equals 3 and x equals negative 2 and then just 3 by itself? Just pick negative.
Just pick the 3, yeah. Okay. Next one, number 2. Okay, again, looking to have a square root, or looking to have the square root by itself, so it is. So I'm going to square both sides. So we got p squared is equal to negative 10 plus 11p. Combine like terms, we got p squared minus 11p plus 10 is equal to 0. I moved everything over to the left-hand side. Factor, we got p minus 1 times p minus 10 is equal to 0. The zero product property, p minus 1 equals 0, and p minus 10 equals 0. So p is equal to 1, and p is equal to 10. Now we want to check to see if these two answers are extraneous or not, so you just do separate problems. So plugging them back into our original equation, so taking away my original annotations, I just want to worry about this up here, okay? So just that portion. So plugging it back in. So P is going to be 1 is equal to square root of negative 10 plus 11 times 1. Yep. Oh, I'm sorry, 11 times, 1. So we got 1 is equal to square root of negative 10 plus 11. 1 is equal to the square root of 1. So square root of 1 is 1. So 1 is equal to 1. Does this make sense? Yeah, it makes sense to me. So this is a good answer. Let's check the other one. P is equal to 10. Putting P in, putting 10 for P. So square root of negative 10 plus 11 times 10. And 11 times 10 is 110. So we're going to put square root of negative 10 plus 110. So 10 is equal to square root of 100. Square root of 100 is equal to 10. So 10 is equal to 10. Is that true? Yeah, that's true. So we're done. Okay, so then both of my answers in this case are included. They're not extraneous, so I want to include both answers. Does that make sense?
So there is no extraneous solution.
There is no extraneous solutions on this one. But on number 1, there was. You see? Okay. So it could happen. Sometimes you might have only one answer. Sometimes you might have two. Sometimes there is no solution. Sometimes you might you might get some answers and then you plug them back in and they are extraneous. So then you would put no solution. Okay? Does that make sense? Any questions on this? Okay, so let's switch it up a little bit. Let's have the 1 still at 2 is about number 2. 2 still at 1 is about number 1. Ready, set, go. Okay, let's do this. Okay, listen up. One last thing. Hey, listen. So this part, this checking your answer part, this is the part when I was in high school I hated doing because it's like, it's another step. But you really need to do it because sometimes your answer will be extraneous. Sometimes both of them. So you might do all this work and it could be all no solution. So number 3, here we go. Number 3 on your whiteboards. Ready, set, go. This one, square both sides. So we got k is equal to k squared. So it's going to be 0 is equal to k squared minus k. You could factor out a k, so k times k minus 1 is equal to 0. So k is equal to 0 and k minus 1 is equal to 0. Or k is equal to 1. Then you check your work. So in your original problem, we got... Original problem, we got k, or square root of k, which is going to be square root of 0 is equal to 0. Square root of 0 is 0, so is 0 equal to 0? Yeah, that works. And then we have square root of 1 equal to 1. Does this work? Yeah, this works too. So they are both solutions. Good. So if you got both answers, good job, Karina. Okay? Number 4. Ready? Set, go. Show you. Here we go. Number 4. So you square both sides, of course. So we got 72 minus n is equal to n squared. So we got 0 is equal to n squared plus n minus 72. So you can factor this as n plus 9 times n minus 8. Is all equal to 0. Zero product property. Students, please end your conversations. You shouldn't be erasing your boards. So we got n is equal to negative 9 and n is equal to 8. Now we have to check them, okay? So plugging in negative 9 first into our original equation. So it's going to be square root of 72 minus a negative 9, right? Because minus n, negative 9, which is all equal to n, which is negative 9. So 72 minus negative 9 is 81, which is equal to negative 9. Square root of 81 is just 9. Is 9 equal to negative 9? No. Extraneous solution. Check the next one now. Next one is 72 minus 8. Square root of that is equal to 8. 72 minus 8 is 64. So we got the square root of 64 is equal to 8. 8 is equal to 8. Does this make sense? Yep. So we only have one answer. N is equal to 8, not 9. Negative 9. Right? Makes sense? So some of you had made a mistake there. Please make sure you correct it. This concludes our lesson.